All right, so lesson number 11 is on the rational roots theorem, which you know is my favorite theorem. I love the rational roots theorem. And something new that you've never seen before, which is the upper and lower bounds theorem. Guys. All right, so the upper and lower bounds theorem are basically going to help you as you're eliminating choices for your rational roots theorem. All right, so the rational roots theorem, or rational zeros theorem, you might hear it called, basically says if you have some kind of polynomial with integer coefficients, every possible rational zero is in the form p over q. Are you all like, oh yeah? All right, where p is a factor of the constant term, so it's the number on the end, so in this case a sub 0, and q is a factor of the leading coefficient, so a sub n in that case. So, a sub n. A sub 0. So it says after we know the possibilities for the zeros, we can check each one with synthetic division. Now you could just plug in, like if you want to see if 2 is a 0, you could plug in 2 into the original function to see if you get 0 out. Right? But that doesn't help us when we're trying to find complex answers, or if we're trying to find answers that have square roots. Okay? Our goal is to take a really long polynomial and factor it. So we want to factor it as much as possible so then we can get all of the weird, strange answers with i's and square roots, okay? So some people last year, this was the first test after J-term, if you remember from last year. And some people just decided that they were going to plug in every single possibility just into the function, and they were like, oh, these work, these don't work, but then they weren't actually finding all of the answers. So I'll talk about kind of the downfall of that as we're doing this. So this one says, find all zeros, real and complex, of p of x equals x cubed plus 3x squared minus 4. So looking at that, it doesn't look like it factors, right? We don't know how to factor something that has x cubed and an x squared. I don't know. So it looks like it doesn't factor, but it actually does, using the rational roots theorem. So what we do is we write p over q. So our factors of p come from the factors of 4. Our factors for q come from factors of 1, right? So for p, I'm going to have 1, 2, and 4, because those are the factors of 4. So they could be plus or minus. And then for q, I have plus or minus 1.
Oh, I love this.
Good. So this gives us 6 different possibilities. So we have 1, 2, 4, but we also have -1, -2, and -4. That would work. Okay, so what I'm saying is a lot of people just plug them into the original, and they were like, oh, that gets me 0. So do you see one that you can just plug something in, and you could be like, oh, that's totally going to give me 0? Right, what's a number that I could plug in?
1.
1 cubed plus 3 times 1 squared. That's 1 plus 3 is 4. Minus 4, that gives me 0. I know 1 is going to work. But just knowing that doesn't tell me all the other answers. The whole reason we do this is so we can factor it. So we're going to have 1x cubed, 3x squared, 0x, minus 4. And we're going to drop the 1. 1 times 1 is 1. Add straight down, I get 4. 1 times 4 is 4. Add straight down, I get 4. 1 times 4 is 4. Add straight down, I get 0. Since our remainder was 0, we have now factored it. It worked. It came out nice and even, right? The remainder was 0, it factors. So it factors p of x into the divisor, which is x minus 1. That's coming from here. And the quotient, which is now x squared plus 4x plus 4. So that's coming from here. It's kind of what we talked about last time, right? There's no remainder. There's no plus r on the end. It's just 0. Do you know how to factor this further? Yeah, you do, right? We know how to factor x squared plus 4x plus 4. We know that it factors into x plus 2 times x plus 2. So our entire function factors into this. You have just learned how to factor something that looks like x cubed plus 3x squared minus 4. And that's why I love this theorem. Because it's like, oh, that doesn't factor. But wait, it does. Right? It does factor. All right, so what are our answers? So if I'm trying to find the zeros, my answers are 1 and -2. -2 is listed twice, right? So Julia, my expert at remembering all of the algebra 2, says that it has what we call multiplicity. Meaning it was listed twice as an answer. Now you guys did have a sneaky question on one of your homework assignments that did ask about multiplicity. Sorry about that. But did you remember what it means? No? It talks about the shape of the graph at those points. So we have 1, and then we have -2. So it's saying we definitely have x-intercepts there. But we know that x cubed, right, if we talk about end behavior, right, the limit as x goes to infinity, blah, blah, blah. The end behavior for x cubed should look like this. But if we only have 2 zeros, it's like, oh, I'm going to go through here. And then, wait a second. It should end up over there. So it has to bounce somewhere. It's going to bounce at the -2. So basically, whenever it has multiplicity 2, it's going to look like, so it looks like x squared on the graph. So it's going to go up, it's going to hit it, and bounce back down. It's going to look like a parabola right there at that 0. And then it's going to go down. What's the y-intercept? Anybody know that?
-4.
-4. 1, 2, 3, 4, because you plug in 0 for the x, and then it goes up. Yep. And we'll go straight through. Yep. It's all coming back. Because they're like, oh, algebra 2, how I missed you. All right. This was a rough chapter, though, after J term. Everybody just kind of had some trouble on that test, if I recall, last year. All right, so number 2. So factor. P of x equals 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8 over the real numbers and find all the real zeros. And I said you might want to use your graphing calculator to help you. So if you remember, if you are on a calculator section, right, you want to use your calculator to your advantage, right? We want to use that as much as possible. So go ahead and put this function in for your y1. Oh, look, I already have it in there. That's so lucky. All right, and then we're going to hit graph. So go ahead and do that. Give me a second.
Oh.
I mean, you can hit zoom 6 if you need to get your standard -10 to 10 window. Can you see it? Do I need to turn off the light a little bit? Okay, so when you graph it, you can kind of cheat, and you can tell where your 0 is going to be. You could actually even use the x-intercept feature on your calculator. So if you weren't sure and you're like, I think that's crossing at 4, let me see. I'm going to go to second trace. I'm going to find the 0, right? So I'm going to do on the left side of the 0. Where am I? Left side of the 0, right side of the 0, guess. And it tells me that my 0 is at 4, 0. So I know that that has to be something that works. But looking at the other ones, does it look like it crosses directly at like 1 or -2 or anything like that? It doesn't really look like it's directly on any of those points. Do you guys see that? It's kind of like, oh no, those don't look good. Those ones look terrible. All right, so let's see. So if that happens, so we know our P over Q, our possibilities are going to be plus or minus 1, 2, 4, and 8 coming from that last number 8. And then for Q, I'm going to have plus or minus 1 and 2, which means I'm going to have 1, 2, 4, 8, -1, -2, -4, -8. But I can also divide by 2. Do I gain any more from dividing by 2? 1/2 and -1/2, right? The other ones, when I divide 2 by 2, I get 1 still. Right, so I could have -1/2 or +1/2. So looking at your calculator, maybe one of them is +1/2 and -1/2. I don't know. Does it look like +1/2 or -1/2? Maybe -1/2. We're hoping. We'll see. So we're going to do our synthetic division. So we said 4 definitely worked. We know it did because we even used the calculator to find the 0. So we're going to have 2, -7, -8, 14, and 8. So it goes 4, 3, 2, 1, none. So I make sure I didn't skip anything. All right, now I do 4 times 2 is 8. I add straight down, I get 1. 4 times 1 is 4. Add straight down, I get -4. -16, -2, -8. It works, which it should have because we just showed it did on our calculator, right? So the whole point of doing this is we've now factored. We factored into x minus 4. And if we started out with something that was x to the 4th, right, it's now going to be x cubed. So we're going to have 2x cubed plus x squared minus 4x minus 2. All right, we want to go more. You could do synthetic division again. So we were hoping that -1/2 works, so we could do -1/2, or we can look at this and we can say, is there any other way to solve this? How can I do this? Ah, split the middle. It does work with split the middle. Do you see the numbers? Like the coefficients are 2 and 1 and -4 and -2. See how those are kind of related? Like you can pull out a -2. All right, so we're going to pull out the x squared. So I have 2x plus 1. Is there any way to get a 2x plus 1 over here? Pull out a number and a sign. -2. So that means that I have my x minus 4 from before. I have my 2x plus 1. And I have x squared minus 2. So if I'm finding my zeros, I set it all equal to 0. So I say x minus 4 equals 0. 2x plus 1 equals 0. X squared minus 2 equals 0. So I get x equals 4. The next one, if I subtract 1 and divide by 2, I get x equals -1/2. And what about the next one? Square root of 2? Ah, thank you, Yaya. Plus or minus the square root of 2. No, because I knew it was plus or minus square root of 2. Right? So I have 4 answers. Remember, if you have x to the 4th, you should have 4 answers in the end if you count multiplicity. So if you had some that were answered twice or whatever. So we have our 4 answers. Those are our zeros. We are done. All right. With the synthetic division, I would never be able to get the plus or minus root 2. Those are not actually rational zeros. You're not going to be able to get those right away, like looking at your graph. You're not going to be like, oh, I think it's crossing at square root of 2. Right? It's probably going to be one that you're going to get as you factor things down. All right, so the next one. So this is where it's kind of a step up from Algebra 2, right? So when I taught Precalc at IU, this is the kind of stuff that we asked. So if you go to college and you take a basic freshman math course, you will be asked these things. So this time it gives us a polynomial, and it says, write the polynomial as the product of linear and irreducible quadratic factors. Irreducible quadratic factors. Okay. And then it says, well, what about the product of linear factors over the complex numbers? And then we're going to find all real and complex zeros, meaning that there's probably zeros that involve I, right? All right, so we can use our calculator to help us if we'd like to. I went ahead and I graphed this one already. Oh, I already deleted it. Man, I thought I had it.
Wait, what are we?
So let's go ahead and see if we can kind of cheat our way through this problem. Like cheating. Because right now, if you look at P over Q, you have several. You have 1, 2, 4, 8. Right, and then -1, -2, -4, -8. So when I graph this, it was really weird. It looked like it went through -2. It looked like maybe it went through 1 and maybe 4. But it was kind of strange. There's a lot going on there. So it does. Maybe this isn't the one that I was thinking was weird. All right, so anyway, so those are the ones that we're probably going to guess. Maybe -2, 1, and 4. Those are our guesses, okay? All right, so let's try 1 first. We always like trying 1 first. So we're going to have 1, -3, -5, 5, -6, and 8. Probably want to write tiny. 1 times 1 is 1. Add straight down, I get -2, -2, -7, -7, -2, -2, -8. Oh, we're so good. 0. We like when it works, don't we? All right, so what we've factored into is x minus 1 times x to the 4th, right, minus 2x cubed minus 7x squared minus 2x minus 8. And that doesn't look like we can split the middle because there's 5 terms, right? So this is an instance where you would have to go again.
No.
All right, so we're going to go again. I thought you said you liked this.
No, how does that
I
like
know.
that.
All right, so let's try -2. So -2, -4, 8, 1, -2, -4, 8, and 0. It works again.
Hey, wow.
So we still have the x minus 1 from before, and now we have an x plus 2 that's represented by the -2 in the backward cell. And then we now have x cubed. Remember, this is always the remainder. This is our number, x, x squared, x cubed, and so on. It's always 1 degree less than what you had before. All right, so I'm going to have x cubed minus 4x squared plus x minus 4. What do we think? Go again? Factor by grouping, right? Split the middle. So we pull out an x squared. We We have x minus 4. We know we want to pull out a number and a sign. So what number and sign must we pull out? A positive 1. So we end up with p of x equals x minus 1 from before, x plus 2 from before, x minus 4 when we pull out that GCF of x minus 4, and x squared plus 1. This is part A. This is what we call the product of irreducible and linear. So linear and irreducible quadratic factors. Okay, linear means x to the first. We have 3 things that are x to the first, right? We have x minus 1, we have x plus 2, we have x minus 4. If I said y equals for each of those, see how they'd be lines? That's why we call them linear. Okay, but what about the x squared plus 1? Does it factor? It is the sum of 2 squares.
X plus 1 minus.
Nope, you would think x plus 1 and x minus 1, but that actually makes x squared minus 1, because the difference is 2 squares. So then people are like, oh, well, what about x plus 1 and x plus 1? But x plus 1 times x plus 1 makes a 2x in the middle. So it actually does not factor. This last thing is what we call prime. Right? It doesn't factor anymore. That's what this means. Irreducible quadratic just means prime. So you're going to factor it all the way down until it's all the linear factors you have, and anything that is still like prime, it doesn't factor down any further. All right, but then B says, well, you can actually write it as linear factors. And that's kind of weird. Maybe I should have done part C first. So if I set each one equal to 0, I end up getting 5 answers like I would expect. The first one is x equals 1. The next one is x equals negative 2. X equals 4. And then when I set x squared plus 1 equal to 0, what are my other 2 answers? Yeah, plus or minus square root of negative 1, which is I. So I get x equals I and x equals negative I. So if those are my solutions, then when I talk about linear factors over the complex numbers, here's how we write it. P of x equals x minus 1, x plus 2, x minus 4, so it starts out the same. But then it tells us that x squared plus 1 actually kind of does factor. It factors into x minus each of the solutions. X minus I and x plus I. Weird, huh? So that is factoring over the complex numbers. We have done it. Okay, so that's how I'll phrase those questions. So I'll say factor it with linear factors and irreducible quadratic factors, and then I'll have another part that says factor it all the way. Factor it with complex numbers. Yes.
Was that 2 of x equals I?
It's x equals I and x equals negative I. Thank you. So yes, write your name on the board, Catherine.
Oh, I was just
No, you can get a bonus point. All right. All right, so the thing that you guys did not like last year about the P over Q, the synthetic division stuff, you didn't like that sometimes you had a whole bunch of possibilities. What if your last term had been 36? So I think that's what the next question is. What if you have 36 for P? Right? When that happens, when you do P over Q, you get 1, 2, 3, 4, 6, 9, 12, 18, and 36. Right? And then can you imagine if I had put like the P or the Q was 27? Oh, you guys would die. You'd be like, I hope this is on the calculator section, but what if it wasn't? Oh.
This is come to.
there would be a walkout.
I know. There has to be some way to eliminate these possibilities. And there is. There's a way to eliminate possibilities. I didn't teach you last year.
Oh my god. We had a question like this.
Alright, I just told you that you can kind of cheat with your calculator, but there is a way to eliminate things. So this is called the upper and lower bound theorem. So it's handy as you're checking things. So as you're checking with synthetic division, if you see that one of these qualifies for upper or lower bound theorem, you can eliminate like half your choices. It's very exciting. Alright, so here's what it says. It says if you are doing your synthetic division and you have C is a positive number. If it's a positive number in here, so let me say positive, and you end up getting all positives or zeros along the bottom row, then that means that's an upper bound. What that means is there are no places where it's crossing the x-axis bigger than that number. So if I try x equals 3, let's say on this one, then that means 4, 6, 9, 12, 18, and 36 cannot be possible. if I saw that I had all zeros or all positive numbers on the bottom. Do you understand what I'm saying? Okay, we'll do some. All right, but if you do your synthetic division, you have a negative number there, and then you alternate. So you go positive, negative, positive, negative, positive, negative. Right, that means it's a lower bound. So let's say you try, looking at this list of numbers, you try -4, and you get that -4 is what we call a lower bound. That means -6, -9, -12, -18, and -36. Those are less than that. Those can't possibly work. Okay? So an upper bound and lower bound just means that if you have an upper bound, and let's say your lower is here, all of your zeros are between here. So every place where it's crossing the x-axis happens between those two values. Does that make sense? So it helps you eliminate different possibilities. So let's say we're trying to find the zeros of this polynomial, and we're like, oh man, this is rough. I don't have my calculator, I don't know what I'm doing. You probably don't want to pick like 1 to begin with. You probably want to pick a number kind of in the middle, because if you get that it's an upper bound, you can eliminate other things. So as you're doing this, let's say you try 6. And you're trying 6, and you're like, okay, I have 1, 3, -9, -31, 0, 36. And you do your synthetic division. Oops. And I get 54, and we start panicking. We're like, oh, I have 45. That's gross. So then you get 270. Ew. And your numbers are just getting even more out of control. But you're seeing that they're all really, really big. And on the bottom, 8604 plus, you don't have to actually write these numbers, it's fine. But as long as you notice that you get all positive numbers, or 0.
I don't think it's 6.
That, I know it's not 6, but what it's telling you is that any 0 you have is going to be less than 6. So with your numbers, shh, guys, with your numbers, you had possibilities. Let me write down all the possibilities. But you also had negative numbers too, like -1, -2, -3, -4, -6. These are all of our possibilities for this problem. It's outrageous, right? You would hate me if I put this on the test. So what we just did is we said, well, it's not 6 because that didn't work. And then 9, 12, 18, and 36 because this was an upper bound. All of those are out as well. So they're gone. We don't have to do them. All right, so we try something else. So let's say we try, I don't know, like -6. So pick a negative number to find a lower bound. So if I try -6, I have 1, 3, -9, -31, 0, and 36. Do you see how it's alternating? Okay, that's what you want. So -85 times -6. So it doesn't matter that we're not getting 0. My goal here is to see that it's an upper bound. Yeah, lower bound, yeah. All right, so it alternates. So this is a lower bound, meaning that's the lowest 0 that we have possible. Now, it didn't work as a 0. We know it didn't work. So that's out, and those ones are out as well. So you could continue to kind of bring your numbers in and eliminate more and more. So the next thing I would probably try would be like 2 or 3. Right, and then I would try like -2 or -3. Does this make sense? And you keep eliminating, eliminating, eliminating. Now, technically, the way I would probably do this problem, if it was on a calculator section, right, I would just do the thing where I'm guessing, where I'm going to put it in, and I'm going to be like, well, it looks like it's going to go through at 4, right, or whatever. So let's go ahead and do that. So put it in for y1, and let's see where it looks like it's going through. So my graph looks like it comes up, it goes down, it touches right at -2, and then it bounces. So then it goes up, it comes down, and goes through 1. Whoops, let me make this look like 1. 1, 2, 3. So it bounces, and then it goes through, and then goes through. So my graph looks like that. So it looks like it bounces at -2. So -2 probably has multiplicity. It looks like it goes through 1, and it looks like it goes through 3. So those would probably be the things that I would try. And those actually are, they do end up being the zeros. So you could finish this out and do the synthetic division, but those are the zeros. So finish synthetic division, your zeros end up being -2 with multiplicity 2, 1, and 3. So if I did do all that work, those would be my answers to me. Okay, does this make sense? But you see how it can be helpful, like useful to know the upper and lower bound theorem. Because if you actually know that theorem, you can get rid of a whole bunch of choices. You're not spending hours and hours and hours doing this. All right, so next one. So find all the real zeros of this polynomial. So if I do my P over Q, I end up getting plus or minus 1, 2, 3, and 6, and plus or minus 1 and 2. All right, has anybody put this in for Y1? This is the one that was weird, I think. Two x squared minus x. Oops. Did you get something strange? It's kind of hard to see. If you need to zoom in, you can. But it looks like it's not going through anything, like any actual integer, nicely. So what I would do, oh, I should have pulled this up on my actual calculator so you can see it. What I would do is I would actually use the calculator function to see which one is a 0, because it looks like maybe like 3 over 2, so 1.5, it looks like maybe that one is. But it looks like also maybe 1/2 and -1/2 are. It's kind of hard to tell. My calculator's, of course, dying right now as I'm doing this. Keeps turning off and on. Maybe I should have listened when it said replace my batteries a million times. All right, so mine looks like it goes through between like -1 and -2, and then it goes off the screen for a little bit, and then it goes through like before 1, and then it comes back down, and it goes in between 1 and 2. It looks something like that. Yeah? So if you do second trace and you try to figure out if one of them is a nice like 0.5 or 1.5 or whatever, so let's see. Did anybody find one? I'm going to do left bound, right bound, guess. It looks like this one right here is 0.5. Okay, so I checked, I made sure that that was 0.5. Only because in 4th period what I did is I went with someone's suggestion, Ian. And Ian was like, it looks like 1.5. So I did 3 over 2 because I thought that was 3 over 2. And I agreed, I thought it looked like 3 over 2. And it wasn't. So I spent too much time doing it. So I now know, I've learned to try 1.5. And it looks frightening when you see this. Because you're like, oh my gosh, I have to do synthetic division with a fraction. But every time it actually works, like if 1/2 was actually going to work, you will never get a fraction throughout the synthetic division problem. If you start getting fractions, you know it doesn't work. So just stop, okay? So when I do 1/2 times 2, what do I get? 1, and I add straight down and I get 0. So 1/2 times 0 is 0. Add straight down, I get -10. So we're good so far. -5, 0. 1/2 times 0 is 0. 12, 6. It worked, okay? So how this factored is x minus 1/2, and then 2x to the 4th minus 10x squared plus 12. So the reason these fractions always work out nicely is because there's always a 2 that can be gained, or a number that can be gained from the other one to make it a nice, see how I can pull out a 2? So I have x to the 4th minus 5x squared plus 6. So now when I factor it, when I multiply in the 2, it looks nicer. You get 2x minus 1 times x to the 4th minus 5x squared plus 6. I asked some of you guys to factor something like this on the first test. You had trouble.
Oh,
X to the fourth. It was really x squared minus 5x plus 6, but you guys did 6 and 1. Do you see it's not 6 and 1? It's x squared minus 3 and x squared minus 2. Right, see how the outer and inner combine to be that negative 5, but the last terms multiply to be positive 6. That's actually what you need. So when you set it all equal to 0, you get 5 answers, like you expect. You get 2x minus 1 equals 0, you get x squared minus 3 equals 0, and you get x squared minus 2 equals 0. So you get x equals 1/2. X squared equals 3, so x equals plus or minus the square root of 3. And x squared equals 2, so you get x equals plus or minus root 2. So you have 5 answers in the end. Okay? So that one was nice. Only finding, there was only one rational root. That was the only thing that was ever going to work with P over Q. The other ones are irrational numbers. They're square root answers, right? So the only thing that ever would have worked was that 1/2. So you gotta, if you use your calculator skills and can find it, then you can still break apart the rest of it to get the other answers. Okay, so see why it's good to know both things. Know how to use your calculator and know how to factor. All right, I think that was the last one, right?